All right, welcome back. Today we got the 7.3 notes. We're looking at parabolas a little more closely today. We're looking at the definition of a parabola from the focus and the directrix. So I know these words are new to us right now, but they'll be more familiar in a few minutes here. Basically, we're taking a closer look at parabolas than we have in the past. All right, so let's start before we dive into the new stuff. Let's look at some stuff that we are familiar with. Here we should already know the parent equation for a parabola. The parent equation is just the simplest form of an equation we can get. And for a parabola, y equals x squared is as simple as we can get. What makes this a parabola? Well, we've got x squared and y to the first. Okay, so we know that's going to be a parabola that opens up or down. We'll get to that in a second. First of all, what is the vertex of this parabola? Well, we didn't add or subtract anything from the x's. We didn't add or subtract anything from the end of our equation, from our y's. So then there's no shifting going on, which means our vertex is going to be at 0, 0. And then what direction is this opening? Well, since this is y equals positive 1 x squared, well, then it's going to be opening up. It's going to look something like this if we drew it. Just a quick little sketch, which is opening up. Okay, pretty basic stuff. Let's go to the next one. How about this? Y equals negative x squared. Okay, what's this one going to look like? Where is this parabola's vertex going to be? Well, there's still no addition or subtraction going on, so we didn't shift this thing anywhere. Our vertex is still going to be at 0, 0. And then which direction is this one opening? Well, since this one is y equals negative 1 x squared, well, then this one's going to be opening down. So we can draw what that's going to look like and write the word down. Okay, so positive a value is going to be opening up, negative a value is going to be opening down. So just a little refresher there. Example 1, here's an equation that may look different, but it's not. Okay, so this one, we've got 12y equals x squared. Now this is kind of like in the last section when we were looking at circles. Our equation is not always given to us in the way that we want it. Okay, so for a parabola, how do we want this thing to be? What do we want our equation to look like? Well, we want it to be basically in y equals form. Okay, so when it's not in y equals form, no big deal. We just got to get it in y equals form. Now, it's not as much work as completing the square, which you may have to do at some point, but not in this section. But here I just want to get y by itself. So normally we'd want to divide by 12. But if I have the parabola y equals x squared over 12, well, that's a little harder to look at. So instead of dividing by 12, we can do something else. We could just multiply by the reciprocal of that number. So instead of dividing by 12, we can multiply by 1 over 12. Okay? And that gives us the same thing. So then that leads to our new equation. 1/12 times 12y is just y equals, and then I got x squared times 1/12. Well, we'll write that as 1/12 times x squared. So 1/12 x squared. Okay, now I have my a value in front, and then I got the squared part next. X squared over 12 means the same thing, but it just looks a little bit different. We like having a number times x squared, so we'll write it like this. All right, so here, what's the vertex going to be for this equation? Well, there's still nothing. I didn't add anything or subtract anything to my x's, and I didn't add or subtract anything from my y's at the end of the equation. So my vertex is still at 0, 0. There's no shifting here. And then let's see, this is y equals positive 1/12 times x squared. So since it's positive, we know the direction is going to be opening up. Okay. So what does the a value do? And now maybe I should have drawn this a little bit wider because 1/12. So try to remember back to when we first learned about parabolas. The a value tells us two things. It tells us the direction and the width. So let's answer that right here. What's the a value and what does it do? It determines. So it determines direction and width. Okay. So the direction, that's pretty easy. If our a value is positive, our parabola is going to be opening up, something like this. If our a value is negative, it's going to be opening down, something like this. Okay. And then the a value, think about it this way. The a value kind of tells us how quickly our parabola is getting tall. Okay. Well, so think of it. If it's getting tall twice as fast as normal, think like a little boy, a little girl, a little kid that is growing twice as fast as everybody else. They're probably going to be real tall and thin, in other words, kind of narrow. Okay. But if someone's growing, 1/12 the speed of everybody else, well, they might be, shorter and wider. Okay. So a number between 0 and 1 is going to give you a wide parabola. A number bigger than 1 is going to give you a skinny parabola, a narrow one. Okay. Now remember, it's not just any fraction. For example, if I said the fraction was 9/7, Well, that's bigger than 1. It's actually going to be skinny. So a fraction doesn't automatically make it wide. A number between 0 and 1 makes it wide. A number bigger than 1 makes it narrow. Okay. All right, so that's pretty much it. What we're looking at there is our a value determines the direction and the width. All right, let's look at another example. So example number 2, we've got negative 32y equals x squared. Okay, so again, we want this thing to be in y equals form. So I want to get rid of that negative 32. Well, I don't want to divide by negative 32 because I don't want a fraction here. I don't want x squared over a number. So instead, let's multiply that by the reciprocal of this thing. And we'll multiply both sides by negative 1 over 32. Squeezing it all in there. And then that's going to give us our equation of y equals negative 1 over 32 times x squared. Okay, all right, so now here we've got our equation. Well, again, there's no shifting going on, so our vertex is at 0, 0. In other words, what can I plug in to make the squared part come out 0? Well, 0. And then what do I get for y when I stick in x as 0? Well, 0 squared is 0, times that is 0, so I get y equals 0. So 0, 0, different ways to look at the vertex. And then the direction, well, since this thing is negative, I know it's going to be opening down. And they didn't ask, but since it's 1 over 32, this would be wider than normal. So our direction would be going down and kind of wide if we want to draw it wide. Doesn't hurt. But anyways, the direction is down. Okay. So what is the a value and what does it do? Well, let's see. They asked what the a value is, so let's write it down. The a value is negative 1 over 32. And what does it do? Well, it made our parabola open down and wide. Okay. So in general, the a value determines the direction and the width. And then, this one we answered more specific to this problem. Since our a value is negative 32, that would be down and wide. Okay. In fact, we can even fill in the specific answer up here. What is the a value and what does it do for this problem? Well, since our a value was 1/12, we could put a equals 1/12. And this one opened up. And since it was 1 over 12, that would also be a wide parabola. Okay, you're going to see a lot of fractions here, but the fractions actually work out nice. You'll see what I mean in a little bit when we start throwing a different little piece of an equation in there. Okay, but we'll get to that in a second. All right, so next, let's get on to the stuff that is going to be new to us today. Relationships among certain features of a parabola. Okay, now we're going to be looking at one of these graphs at a time. Let me zoom in so we can see a little bit better. All right, so what is a parabola? This unit's about parabolas and circles. Let's ask a simpler question. What is a circle? So if I have a circle, and I drew this one, so it's not perfect here, but what is a circle? Oops, sorry about that. Okay, so a circle is the set of all points equidistant from a given point. Okay, so that given point is our center, and the set of all points equidistant from that is just all the points on the edge of my circle. Because if this is drawn correctly, well then, every point on the edge of the circle is the same distance away from the center. What do we call that distance? Well, that's the radius. So again, a circle is the set of all points equidistant from a given point. Okay, great. Makes sense. What is a parabola? Okay, so a parabola, this one might not be as obvious because we haven't really thought about it like this before. But a parabola is the set of all points equidistant from a given point and a line. Okay, that point is going to be somewhere inside of your parabola, right about here. Okay, and we call that point the focus. Okay, we'll label this stuff in a minute, but first let's draw some other pieces and then I'll label them so I don't have lines going over other lines. So we call that the focus, and then the given line, we call that the directrix. Here we can label that down here. Directrix. Okay? All right, so again, a parabola is a set of all points equidistant from a given point and a line. So every point on my parabola should be the same distance away from this point here and this line here. Now the one in the middle of those two things is what we're most familiar with. This point right here would be our vertex. Okay, now again, according to the definition, that means that this distance here and this distance here are both the same. Okay, and we call that distance the focal length. Okay, and in our equations, we just picked a letter we don't use very often. We call that distance c. So c is our focal length. It's the distance from the vertex to our directrix here, and our vertex to our focus here. Okay, so that distance is c for both these things. When I changed the font size, I may have accidentally stretched this thing out. The parabola doesn't look quite right, but we're going to label the correct distances even if they are not quite drawn to scale. Okay, so anyways, this distance is c. That's called my focal length. Now, if I go straight to the side from my focus to the edge of my parabola here, again, this is something must have changed. I think I might have changed the font. Sorry about that. But this distance here is always going to be 2 times my focal length. And then same thing going the other direction. This distance here would be also 2 times my focal length, which means from, and we call this our focal length chord endpoints, okay? From here all the way to here would be 4c. Okay, so then these are a couple relationships that we're going to start paying attention to from now on. Okay, again, the main one being the focal length, which is the distance from my vertex to my focus, and from my vertex to my directrix. Okay, and we'll label that focus now that we can see it. So our focus is right there. Okay, and again, something I briefly mentioned, this is our focal chord. If I go straight, horizontal through the focus, I get this little chord that goes through my parabola. That's called the focal chord. The length of that focal chord is 4c. It's 4 times my focal length. And from my focus to my focal chord endpoint, that's 2c this way and 2c that way as well. Okay, and remember, c is our focal length. Okay, so I'm sorry this looks a little stretched out. I'm not sure why it did that when I printed it. But again, don't go off looks. Go with what it should be mathematically. Focal length here, 2 times my focal length here, and this should be 4 times my focal length straight across. Okay? All right, so better zoom out a little bit so we can see the words here. Whoops. All right, so as you can see, the c value is very important. That focal length is very important, and it's called the focal length. There are several relationships built around that c value. We pretty much just labeled them all right here. Okay, and then the formula for finding our focal length. This is very important. Go grab a highlighter. This is something, if you don't have a highlighter, just circle it, put a star around it, whatever. That little equation right there is very important, because if I want to find out, well, where is my focus? Where is my directrix? How far away from my vertex do I need to go to get to those things? Well, this is how we find it. So our focal length is just 1 over 4 times our a value. Okay? All right. Now, like it says here, let's go back to example number 1 and determine the c value. Once we know the focal length, we can find everything else. Okay? All right, and again, this parabola printed a little bit funky, and I don't want to draw on it too much, and you don't even have to draw these things, but keep in mind, this distance here should be the same as this distance here, and that goes for any point on my parabola. If I pick this point up here, for example, well, then the distance from my focus to that point should be the same as the distance from that point to my directrix. Now, again, this parabola didn't quite print out. This might not be a true parabola, but these two distances should be the same. Same thing, here. This distance should be the same as this distance. They're obviously not, so again, this didn't print quite correctly, but that's the definition of a parabola. Every point on my parabola should be the same distance away from the focus as it is from the directrix, and it's always straight down to the directrix and then straight over to my focus. Okay, so again, sorry these didn't print correctly, but that's okay. All right, so let's see. They want us to go back to example 1. Since we don't want to have everything be printed too small, let's just rewrite that equation. Our equation, after we put it in the form we wanted it to be in, was y equals 1/12 times x squared. Okay, and then we want to find the focal length. So the focal length that's what we call c, and our equation for c is 1 over 4a. So then that's going to be 1 over 4 times whatever my a value is, which our a value was 1 over 12. Okay, which gives us 1 over 4 times 1/12, we get 4 over 12, which reduces to 1/3. And then how many times does 1/3 go into 1? Okay, now you can do it that way, or remember that dividing by anything is the same as multiplying by its reciprocal. So 1 divided by 1 over 3 is the same as 1 times 3 over 1, which is just 3. Okay, so then our focal length is 3. And now let's draw and label all these different pieces that we just learned about up here. And we'll do that on this graph here, for example number 1. Okay, so let's see our vertex. Well, obviously it's right here, so we'll just label this. And we know that's it at 0, 0 because we already figured that out. Okay. All right, well then if that's at 0, 0, where is my focus going to be? So it should be the same distance away from the directrix, so maybe right about there. And then where is that focus going to be? Well, I went up, so then it's going to change my y value. And we went up how far? Well, our focal length is 3. So if I'm at a y value of 0 and I go up 3, that's going to put me at the point 0, 3. Okay, what about my directrix? Okay, now since the directrix is a horizontal line for an up-down parabola, it's always going to be a line y equals. And then what's the y value of every point on this line? Well, again, we were at a y value of 0, we went down 3, so it's going to be y equals -3. Okay, if I wanted to know where my focal chord endpoints are going to be, that's going straight out from my focus in both directions. So right there and right there. Where are these 2 points going to be? Okay, now remember your focal chord endpoints are always going to share either an x or a y value with your focus. In this case, for an up-down parabola, this one particularly opening up, it's going to have the same y value. I'm not going to change the y value of 3, I'm just going to change the x value. I'm going to go left or right. So I know it's going to be something comma 3 and something comma 3. And then how far do we have to go over to get to my focal chord endpoints? Remember that distance is going to be twice my focal length. So since my focal length is 3, 2 times 3 is 6, that means I'm going to go right 6 to put me at 6, 3, and left 6 to put me at -6, 3. And then now we have all the things that we wanted, and it all came from knowing our focal length, which was 3. Okay, so once we know our vertex and our focal length, we can find our focus, our directrix, and our focal chord endpoints. And that's what they're going to ask you to do on a lot of your homework problems. Okay, all right, let's take a look at the next example, which has us find all of that stuff. And I'll zoom out so we can see everything at once. Don't have to shift the page around so much. Sorry if the writing is small, but hopefully you have this page out in front of you anyways. All right, so example number 3, where they want us to graph the parabola x squared equals 8y. And we want to find and graph the focus, directrix, and focal chord endpoints. So this is going to be kind of standard. This is what they're going to ask us to do a lot of the time. All right, now the first thing we want to do, we don't like the way that equation is written, so let's write it a different way. We want to write it in y equals form. So I want to get rid of that 8. I don't have a lot of room to show my work, but to get rid of the 8, we can multiply by 1 over 8, and then that would give me y equals 1/8 times x squared for my equation. Okay, now from our equation, we can already see that the vertex, since there's no shifting, which is going to be the case for the whole worksheet here, my vertex is going to be at 0, 0. It gets a little trickier when the vertex is not at 0, 0. It's the same kind of work. It's just it's not as easy to get your focus directrix, because it's easy when you're moving from the origin, because if I'm going up 3, it's just my y value becomes 3. If I'm going down 2, my y value becomes -2. When you're moving from a different coordinate, it's not any harder. It's just a little bit harder to keep track of, I guess. All right, and then to find the focus and the directrix and the focal chord endpoints, well, for all that stuff, I need to know what is my focal length. So we want to find the focal length, which we know is c, and our equation for c is 1 over 4a. You don't need to write all this stuff every time. This is just practice until we get it memorized. And so that's going to be 1 over 4 times my a value, which is 1/8, which gives us 1 over 4 times 1/8 is 4/8, which reduces to 1/2. And then 1 divided by 1/2 is the same as 1 times 2 over 1, which is 2. Okay, so we know our focal length is 2. All right, so let's see. First of all, also, if you plug in your a value and it's negative, so if we get -2, just remember this distance always takes you to your focus first. And then if you go the opposite direction, you're going to hit your directrix. okay? Or just pay attention to which direction your parabola is opening. Our parabola is opening up, so I know that I'm going to go up to my focus. If it was opening down, then I would go down to my focus. So you can always use positive numbers, just know if you're going to your focus or your directrix first. All right, so anyways, our vertex is here at 0, 0, so we can plot that point. And then since my focal length is 2, I'm going to go up 2, and then that's where my focus is, which again, we mark that with a star, so we know the difference. Just a little star there. I'm going to go up 2 to my focus, which means I got to go down 2 from my vertex to get to my directrix. So my directrix is going to be a horizontal line. It doesn't have to be dotted, but I like to make it dotted. Okay, so I got my focus and my directrix, and then I could draw my parabola, but to make it a little bit more accurate, especially since we have to label them, let's find out exactly where these focal chord endpoints go. Okay, now before we get too far ahead of ourselves, let's label the focus and the directrix, which we already drew. I can see the focus is right here at 0, 2. And then remember, your directrix is always y equals, and then, well, what's the y value of every point on this line? Well, -2. Okay, next, where are my focal chord endpoints? Okay, well, since my focal length is 2, that means I have to go out double that to get to my focal chord endpoints. So I got to go out 4 in each direction. Okay, and then once I have my focal chord endpoints, well, first of all, where are those? 4, 2, and -4, 2. And then now I can draw my parabola a little bit more accurately since I have these extra points there. And as you can see, this one's going to be wide and opening up, which, yeah, that looks right because our A value is 1/8 and it's positive 1/8, so it's opening up. Okay, so anyways, there's example number 3. So as you can see, all these new parts, the focus and the directrix and the focal chord endpoints, those aren't that hard to find as long as we know what our focal length is. Okay, so again, this equation for focal length, 1/4a, very important to us. All right, example number 4, next one here. Graph the parabola x squared equals -6y. Find and graph the focus, directrix, and focal chord endpoints. So pretty much same thing as they wanted on the last one. Okay. Here, again, we don't have an y equals form. We want to get our equation in y equals form. And to do that, we would multiply by -1/6, which would give us the equation y equals -1/6 x squared. Okay. All right, now before we start drawing stuff, keep in mind, which way is this opening? Down, and it should be a little bit wider than normal. Okay, but we know it's definitely opening down, which means we're going to go down to our focus and up to our directrix. All right, so first of all, where is our vertex? Well, again, there's no shifting going on yet, so it's at 0, 0. And then for our focus, directrix, and focal chord endpoints, for all that stuff, we want to find the focal length. So let's scoot this up a little bit more. We got a little bit of space at the bottom, so we'll do it here. Our focal length is what we call C. Our equation for the focal length, C, is 1/4a. So then that's going to be 1/4 times our A value, which is -1/6. So I got to write that kind of small. Again, that says 1/4 times -1/6. Okay, which is 1/4 times -1/6 is -4/6, which reduces to -2/3. And then remember, dividing by 2/3 is the same as multiplying by 3/2. So I get 1 times 3/2, which is 3/2. Okay, and again, technically it's negative, which means we're going down to our focus first, but we already knew that because it's opening down, right? Okay, so let's see. 3/2, remember that's just 1.5 when you're actually graphing these things. Okay, so from my vertex, which is at 0, 0, I want to go down 1.5 to my focus, so just draw a little star down there at about 1.5, and then go up 1.5, and then draw that horizontal line, which we call our directrix. Okay, so good enough, something like that. All right, let's label these before we move on. Our focus is at 0, -1.5, and you can write that as a fraction or a decimal. It doesn't really matter. I'll use a fraction. So we're at 0, -3/2. And then our directrix, well, from the y value of 0, we went up 1.5, up 3 over 2. So then it's going to be y equals positive 3 over 2. Okay, the next, where are our focal chord endpoints? So it's going to be some point and some other point. Okay, so remember, from our focus to get to our focal chord endpoints, I want to go left and right, double my focal length. Well, my focal length is 1.5, so double that would be 3. So I want to go left 3 and right 3. Then that gives me my focal chord endpoints. So those are going to be at what? Now, like I said earlier, your focal chord endpoints are always going to share either an x value or a y value with your focus. These have the same height as my focus, so then they're going to have a y value of negative 3 over 2. Okay, and then how far left and right did I go from a x value of 0 to get here and here? Well, I went left 3 and right 3. So negative 3 comma negative 3 over 2 and positive 3 comma 3 over 2. Those are going to be the coordinates of our focal chord endpoints. And then finally, we can do a quick sketch of our parabola. It's going to look something about like that. All right. Now, the last example is a little bit different. Hopefully, you guys can read that. I'm sorry, I know it's kind of small on the screen there. So it says, for the parabola with a focus of 0, negative 2 and a directrix of y equals 2, use the formal definition of a parabola to derive the equation in descriptive form. Okay, now if you use the formal definition of a parabola, you have to use the distance formula. Okay, so I want you guys to ask yourself something right now. So I'm going to ask you a question. Think about this. How many of you know the distance formula and can write it down from memory right now? Probably very few of you. Okay, so we're going to do something a little different. We're going to kind of use some common sense and then use the focal length to find the equation instead. Okay, and then really, what do we need to find? We need to find the equation of a parabola. Okay, well, what does that look like? Well, it's going to be in y equals form. I'm going to have some a value times the squared part. Now, the squared part doesn't just have to be x squared. It might be x plus or minus something else. So in general, we say x minus h squared. But again, h could be 0, which would just give us x squared. And then we might have plus, or minus some other number at the end. So our general form of our equation, we say plus k. All right. So let's see. For this whole section, our vertices, our vertex, is always going to be at 0, 0. So h is 0 and k is 0. So really, our equations are going to look more like this. Y equals something times x squared. Okay, so really all we need to do to get our equation here is figure out what is our a value. And then to solve for a, we just need an equation with a in it. Well, this one doesn't really do because we got y and x in there. But what else has a in it? Well, how about our equation c equals 1 over 4a? If I know what c is, so ignore all this other stuff. If I know what c is, I can plug in that number for c and then solve for a. So then that's how we're going to find this equation. Okay. Now, to help us visualize this, though, let's draw it before we get started. All right, so let's see. We'll draw an axis to start. And then let's see, we've got a focus at 0, negative 2. So I'm going to go down 2 and then draw my focus. I've got a directrix of y equals 2, so then I'm going to go up 2, 1, 2, and then draw my directrix. So here's my focus, here's my directrix. And then just think, oops, sorry about that. So think about it, where is our vertex going to be? Well, it's always going to be right in the middle of the directrix and the focus. So what's right in the middle of these 2 points? Well, that'd be right here at the origin. Okay, which is why we're going to have an equation that looks like this, because h and k are both 0, because the coordinates of the vertex here are at 0, 0. Okay, so great. Now I just need to know what's my a value. And then how do we figure out that a value? Well, like we talked about earlier, we can find the a value if we know the focal length. What is the focal length? How far is it from my vertex to my focus? Well, this is at 0, 0. This is at 0, negative 2. So then it's negative 2. Now you can use negative 2 or positive 2. Just keep in mind, since my focus is down here, my parabola is going to kind of wrap around that focus. In other words, my parabola is going to be opening which direction? Well, it's going to be opening down. So then I know my a value should be negative. So if you just keep that in mind, you know, putting it down here where we're going to stick our answer, my equation is going to be y equals negative something times x squared. So I already know that should be negative. And then you can either use positive 2 and just keep in mind that it's going to be negative, or stick in negative 2 and it'll give you a negative answer. It's up to you. We'll do the proper algebra way. We'll stick in negative 2 so we get an actual negative answer. Okay, but since it's a distance and if you just want to use a positive number, you can. Just pay attention to which way your parabola is opening. Then you'll know whether or not it's supposed to be positive or negative. All right, so let's see. We want to use the equation c equals 1 over 4a. Okay, because again, to solve for a, I need an equation with a in it. Well, this has a in it, and I know what c is, so then I can use this equation. We know c is negative 2, so we get negative 2 equals 1 over 4a. And now I have an equation with just a in it as my variable, so now I can solve for a. Okay. All right, these are pretty much always solved the same way. We want to get rid of the fraction. Well, let's multiply by the denominator then. So multiply both sides by 4a. And then will those reduce, and I get negative 8a equals 1. And then now to get a by itself, divide both sides by negative 8. And then those reduce, and I get a equals negative 1/8. So then plug that into my equation, and I get y equals negative 1/8 times x squared, and that is my equation. Okay, so again, if they give you the focus and the directrix and ask you to find the equation, well, first of all, what's your equation going to look like? One of these two forms. Okay, for this whole first section, they're all going to look like this because our vertex is always going to be at 0, 0. We just need to find the a value. Okay, now draw it to give you a better visual, and then see, okay, what is my focal length? How far is it from my vertex to my focus? And remember, your vertex is always right in the middle of your focus and your directrix. So how far is it from here to here? And then plug that number in for c, and then you can solve for a. And once you have your a value, it's just y equals that a value times x squared. Okay. So anyways, diving deeper into parabolas today. Hopefully this made sense. If not, please ask questions when I see you next.